Hey guys, welcome to my video for 17.1, angles of rotation in radian measure. Good news, we're at trigonometry. Bad news, some people get confused and don't understand this for about a week. That would be me. When I was your age, I took this in, it was in pre-calc, it wasn't in Algebra 2, and this confused me for a while. But the first part wasn't bad, and so I'm going to work on that with you guys right now. The first thing is called coterminal angles, and the first thing I need to teach you is that when we're drawing a coordinate grid, if we're going to use it for angles only, so I'm just going to make a quick coordinate grid. I should be using a ruler. So this is what you and I would consider x, and this is what you and I would consider y, of course. If we're doing angle measurements, we measure this as 0. So the x-axis is 0, not the y-axis, but the x-axis. So that's where everything has started. Now you know a full circle makes 360 degrees, so if we went from here all the way around, we'd have 360 degrees, right? And so we only open in the positive direction this way. So if I was to say, hey, I need a 45 degree angle, what I mean by that is I want one line here and one line here, and that is a positive 45 degree angle, the distance from there to there. So this is clearly a 90 degree angle all the way across, and laying flat on the ground would be a 180 degree angle, what you and I would call a straight line, and you would have learned that in geometry as well. So that's the first part for you guys to understand, is that everything starts here at 0, and anything past 180 degrees is going to come down here. If someone said they wanted a 360 degree angle, then they're asking you to put one line here and then measure opening all the way around until it gets back to here flat, and you would have a line like that. So it wouldn't have any height at all. It would just be two lines laying on top of each other, and that would be 360 degrees. So this word coterminal means they want you to do a different way of saying that same angle, but from a different degree. So there's two ways to do it. You can spin around from the negative angle, or you can spin around more than one whole time. So let me do another one. So I'm going to draw a coordinate grid here, and I'm going to do a 135 degree angle. So that would be the distance from here to here, a 45 degree angle over there. That would add up to a total of 135 degrees. Okay, if I wanted to end up in the same place, that's what coterminal means, but I wanted to go about it in a different direction. I don't want to just go from here to here. I could go backwards. I could go this direction, the negative direction. And I could get all the way to here and end up in the same exact spot. Almost like if one of your friends was in a classroom and another friend was in a different classroom, and you guys wanted to meet at the same spot. You wouldn't necessarily meet right in the middle, but one of you would go in one direction, one of you would go in the exact opposite direction. That's what's happening here. One friend is going this way, they're opening their angle in that direction. The other friend is opening their angle in this direction. So the question is, how far do you have to go in the negative direction to be in the same spot as 135? Well, you can see by my drawing, it ends up being a circle. So if you take 360 degrees, you subtract 135 from it, you realize you've used up 135 of the 360 degrees. If you go another 225 degrees, it adds up to a total of 360, and that's how you find your missing angle. So to 135 and negative 225 are the same distance. Really, I shouldn't call them the same distance. Really, I should say they end up in the same spot. So 135 and negative 225. The other way you can do it is you can go all the way around. You could have a friend. Imagine you had a friend who was standing looking in this direction right here at the center. We're like looking at the top of their head, and they're looking this way. If they spin 135 degrees, they're looking this way. Well, if you spun them around an entire loop and then another 135 degrees, they'd be spinning in the same direction. So if you go 360 degrees, you would get back to where you started, and then go another 135, you would end up in the same spot. So 495 is the same as 135, which is the same as negative 225. All right, let's do another example, see if you guys can do it. If you feel like you're starting to understand, you can stop the video and try to get the answers yourself. If you don't, you can just wait until I give you the answer. Okay, so I'm going to go past 180 degrees this time. I'm going to go all the way to to a famous angle in trig, 210 degrees. So if that's 180, I'd be opening a little further than 180, about 30 degrees further than 180, and I'd be going 210 degrees. So my question to you, and you can pause it if you want to, would be, how could you get here going in the negative direction? And how could you get there by spinning all the way around 360 and then going the same distance? Okay? All right, I'm going to go ahead and answer it. If you didn't pause it, that's okay. So the first way would be the backwards way. So if you've already gone 210 degrees, you can take that away from 360 degrees. And you'll realize that 210 and negative 150 are the same. Positive 210 and negative 150 would get you guys in the exact same spot. The second way of doing it is by saying I'm going to spin around 360 degrees, and then I'm going to go another 210, just like I did originally. So that would end up being 570 degrees. So 210, negative 150, and positive 570 would all be coterminal. They would all end up in the exact same spot. All right, that's going to be the end of our first section.